Somewhere beyond the familiar constellations, a shadow drifts through the void, a traveler from another star system whose origins are as mysterious as its trajectory. Astronomers at Harvard and around the world watch with equal parts fascination and unease, because this is no ordinary asteroid or comet. It is an interstellar object, moving through space at a velocity and trajectory that suggests it has wandered across light years, untouched by any single star's gravity until now. And as scientists calculate its path, its speed, and its potential, a chilling question arises. What is it? And what might it mean for our place in the cosmos? Interstellar objects are exceedingly rare. The first confirmed visitor, Oumuamua, discovered in 2017, stunned astronomers with its elongated shape, unusual acceleration, and mysterious origin. At first, many speculated it was a comet, a fragment of debris from another solar system. Yet its motion, tumbling rotation, and lack of detectable outgassing defied conventional explanations. Some even posited more speculative theories, including artificial origin, an idea that sparked debate and awe in equal measure. Now, years later, a new object appears on the horizon, triggering alarms at institutions like Harvard. Its discovery is recent, its trajectory uncertain, and its behavior unusual enough to demand the most rigorous scrutiny. To understand why this object causes fear, one must appreciate the physics of interstellar space. An object traveling at tens of kilometers per second carries immense kinetic energy. Even a fragment the size of a city could release more energy than the most powerful nuclear weapons if it collided with Earth. While probability suggests such an event is exceedingly unlikely, the mere fact that the object is not bound to our solar system, that it came from the dark reaches between stars, changes the calculation. It is a wanderer with unknown composition, unknown mass, and unknown potential for interaction with our planetary neighborhood. The unknown breeds both scientific curiosity and existential concern. And the fear is not merely physical. Interstellar objects challenge our understanding of planetary formation, stellar dynamics, and even the possibility of life beyond the solar system. Oumuamua forced astronomers to confront the notion that our sun is not isolated, that objects can traverse interstellar distances, unbound and undetectable until they approach closely enough for observation. Each new discovery adds urgency to questions about cosmic threats, the fragility of our planetary environment, and the limits of human foresight. Harvard scientists, equipped with the most advanced instruments and simulations, understand that a seemingly minor anomaly could reveal profound truths, or hazards, about the universe we inhabit. The trajectory of the new object is particularly troubling. Unlike typical comets, which are bound by the sun's gravity and follow predictable elliptical orbits, this interstellar visitor moves hyperbolically, meaning it will pass through the solar system only once. Its path cannot be altered by conventional planetary interactions in any meaningful way. If it comes close to Earth, its behavior could be catastrophic or merely observationally curious. The uncertainty is enough to keep scientists awake at night, calculating scenarios, running simulations, and searching for subtle clues in its reflected light. Moreover, its composition is unknown. It could be a rocky fragment, metallic debris, or something more exotic. Its origin, whether ejected from a distant star system during planetary formation or flung out by gravitational interactions with massive stars, remains a mystery. The challenge for scientists is twofold: to track and predict its path with precision, and to analyze its physical properties using only indirect observational data. Every photon of reflected sunlight, every spectral line, every change in brightness carries information, yet the margin for error is vast. The universe is offering a puzzle, a potential warning, and an opportunity for discovery simultaneously. And as astronomers peer into the sky, searching for faint signals, the existential implications loom large. The universe is not a static, safe place. Stars explode, asteroids collide, and interstellar debris crosses paths with planets without warning. The arrival of an object from beyond our solar system is a stark reminder that cosmic events occur on scales and timelines far beyond human control. Harvard scientists and their peers are not merely studying a rock in space. They are confronting the reality that the universe is dynamic, unpredictable, and occasionally dangerous. If the tension of this interstellar enigma excites you, then 404 Altverse is your portal. Subscribe and join us as we follow these cosmic wanderers, explore their mysteries, and probe the very edges of what humanity can understand. Each object, each trajectory, is a story of motion, energy, and possibility, and sometimes of fear. Even the detection of the object is remarkable. Astronomers rely on sky surveys, wide-field telescopes, and automated detection algorithms to spot moving points of light against a static backdrop of stars. The faint glimmer of an interstellar visitor requires exquisite timing, patience, and precision. Once detected, calculations of its orbit must account for gravitational perturbations, solar radiation pressure, and potential outgassing. Each factor introduces uncertainty, complicating predictions and intensifying the need for vigilance. Scientists understand that the unknown nature of this object makes prediction challenging, and in space, unpredictability can be consequential. As the interstellar object hurtles through space, the urgency intensifies. Its trajectory carries it past the familiar planets, moons, and belts of our solar system. Yet every observation, every measurement, raises new questions. Its velocity is extraordinary, exceeding that of most solar system bodies, suggesting that it was ejected from its home star system with tremendous energy. How did it achieve such a trajectory? What event catapulted it across light years of emptiness to pass through our celestial neighborhood? The answers lie somewhere in the violent processes of stellar formation. Perhaps a planetary collision, a close encounter with a massive star, or even gravitational slingshots in a chaotic young system. Yet these scenarios, while plausible, remain speculative. Each possibility paints a picture of a universe far more dynamic, violent, and unpredictable than we often imagine. Scientists at Harvard are racing to capture every photon, every reflection of sunlight off its surface, attempting to deduce its shape, rotation, and composition. The object's brightness varies in ways that hint at irregular shape or tumbling motion, reminiscent of Oumuamua's elongated profile. Some observations suggest it might not be a simple rock or ice fragment, but a body with unusual properties, denser in some regions, reflective in others, behaving unlike any object native to our solar system. The fear is not merely theoretical. An unknown mass with unknown behavior moving at tens of kilometers per second carries energy capable of massive destruction if an unlikely collision occurs. The margins of error are narrow, and even small miscalculations could have profound consequences for predictions. Yet the threat is not solely physical. The arrival of an interstellar object challenges humanity's sense of cosmic security. Our planet, comfortably cradled within the sun's gravity, appears insulated from cosmic chaos. And yet, the universe is vast, dynamic, and indifferent. For billions of years, countless objects have wandered the void, many destined for oblivion, some potentially intersecting with worlds capable of life. The new interstellar object is a reminder that the universe operates on scales and timescales far beyond human comprehension, and that even seemingly rare events are inevitable over cosmic history. Harvard scientists, armed with simulations and decades of observational data, are acutely aware that understanding is both empowering and humbling. The physics of such an object is extraordinary. Traveling at high velocities, it interacts with the solar system in subtle but measurable ways. Gravitational interactions with planets, particularly Jupiter and Saturn, may alter its path slightly, nudging it along a trajectory that can be predicted, but never with absolute certainty. Solar radiation exerts pressure, tiny but persistent, pushing the object along its path. Outgassing, if it behaves like a comet, can produce thrust in unexpected directions. Every factor is calculated meticulously, yet the unknown dominates. Each small uncertainty multiplies over distance and time, making precise predictions difficult. The fear arises not from certainty of danger, but from the sheer scale of unknown variables, the cosmic complexity that cannot be tamed. Astronomers have also begun to speculate about the object's origin, delving into the chaotic processes of other star systems. Perhaps it was ejected during the formation of planets around a distant star, or perhaps it is a remnant of a cataclysmic collision, frozen in space for millions of years before arriving in our solar system. Some even propose more speculative ideas, that it could be artificial, a relic of alien technology designed to explore or observe, much like a cosmic probe. While there is no evidence to support such notions conclusively, the unusual behavior of the object ensures that every possibility is weighed, every scenario modeled. The unknown evokes both awe and unease, a reminder that the universe is far more complex, creative, and indifferent than our minds are prepared to fully grasp. The psychological dimension cannot be underestimated. Scientists lie awake, considering worst-case scenarios, exploring the boundaries of probability and consequence. The object could be harmless, merely a rock passing silently through the void, or it could represent a collision risk or another unexpected threat. Even if the probability of catastrophe is extremely low, the stakes are astronomical. This tension between low probability and high consequence is what drives research, observation, and caution. Harvard scientists and the global astronomical community understand that the universe does not conform to human schedules, desires, or perceptions. It simply unfolds, indifferent to life, civilization, or comprehension. And yet, within this tension lies wonder. Interstellar objects are messengers from other worlds, fragments of systems we can never visit, yet now passing through our cosmic backyard. They carry information about planetary formation, stellar evolution, and the dynamics of other star systems. By studying them, scientists glean insights into processes occurring light years away, revealing patterns and anomalies that expand our understanding of the cosmos. Every observation is a dialogue with the universe, a conversation across unimaginable distances, a chance to touch the unknown. If the suspense and discovery of these cosmic wanderers fascinate you, then 404 Altverse is where these stories unfold. Subscribe and explore with us the travelers from the stars, the silent emissaries that challenge our knowledge, and the mysteries that remind us how vast and unpredictable reality truly is. The universe may send these objects at random, yet each encounter is an invitation to wonder, discovery, and vigilance. As the object approaches, instruments scan for signs of activity, rotation rates, surface reflection spectra, and any detectable outgassing. Telescopes capture subtle variations in brightness, hinting at tumbling or irregular shape. Radio observatories listen for emissions, though none are expected. Yet even the absence of signal is information, suggesting a surface composition unlike typical solar system bodies. Every new measurement narrows possibilities, but the uncertainty persists. The object remains fundamentally alien, a puzzle of origin, structure, and potential consequence. The arrival of this interstellar visitor is also a stark reminder of humanity's vulnerability and ingenuity. While the probability of collision remains extremely low, it underscores the importance of monitoring, modeling, and understanding the cosmos. It is a humbling affirmation that even in our relative safety, the universe is alive with motion, energy, and surprises. The same laws of physics that keep Earth in orbit also govern these travelers, yet the scales, distances, and energies involved are beyond ordinary intuition. The new object is a wake-up call, a reminder that the universe is not merely a backdrop for life, but an active, dynamic, and sometimes terrifying environment. As the interstellar object continues its approach, the tension among scientists intensifies. Observatories across the globe focus their instruments, capturing every photon, every faint reflection of sunlight, every nuance of movement. The data is pouring in, but each new measurement raises more questions than it answers. Its irregular rotation, unusual trajectory, and unexpected acceleration suggest that this is no ordinary comet, asteroid, or fragment of planetary debris. Every simulation must account for unknown variables: composition, density, mass distribution, and interaction with solar radiation. The unknown is enormous, and even the slightest error in measurement can magnify into divergent predictions over millions of kilometers of travel. The kinetic energy of the object is staggering. Moving at tens of kilometers per second, it carries force that could alter the fate of planets, moons, or smaller bodies it encounters. Even a fragment only a few hundred meters across could release energy equivalent to billions of tons of TNT. The universe rarely acts with malice, yet indifference can be just as terrifying. Harvard scientists, aware of this reality, calculate not just trajectories but potential impact probabilities, energy dispersions, and cascading consequences. While the odds of direct collision with Earth remain low, the implications of a miscalculation or unforeseen interaction cannot be ignored. But the object is also a messenger, a relic from distant star systems. Its very existence challenges assumptions about planetary system formation and the frequency of interstellar debris. Some theorists propose that such objects could be commonplace, wandering silently for billions of years, invisible to our telescopes until they happen to cross our solar neighborhood. Others speculate on more exotic possibilities. Could the object be the result of advanced extraterrestrial engineering, a probe or artifact ejected into interstellar space? While there is no evidence to confirm such speculation, the mere suggestion emphasizes how little we truly know about the universe beyond our immediate cosmic neighborhood. The line between awe and unease is razor-thin. As astronomers track its path, simulations reveal how gravitational interactions could alter its trajectory. Encounters with Jupiter or Saturn could slightly shift its orbit, potentially directing it closer to or farther from the inner solar system. Solar radiation pressure could nudge it subtly, creating additional uncertainties. If it contains volatile ices, outgassing could accelerate or decelerate its motion in unpredictable ways. Each calculation is a reminder of the sensitivity of celestial mechanics, where tiny forces acting over millions of kilometers can determine whether a cosmic traveler passes harmlessly by or poses a tangible threat. The object becomes a symbol of uncertainty itself, a reminder that the universe operates on scales that dwarf human intuition. And yet, amid the tension, there is discovery. Instruments capture its spectral signature, hinting at minerals, ices, or metallic compositions unseen in typical solar system bodies. The variations in reflection reveal a tumbling, elongated shape, suggesting a violent past, perhaps an ejection from its home system during planetary formation or a collision with a massive object. Each new insight adds a piece to the puzzle, yet the broader question remains: what does it mean that such objects traverse the void, indifferent to stars, planets, or life? The universe is active, dynamic, and occasionally terrifying, and humanity's understanding is always partial, provisional, and evolving. Philosophically, the arrival of this object forces reflection on humanity's place in the cosmos. We are privileged observers on a small planet, yet our cosmic neighborhood is far more crowded and dynamic than daily life suggests. The universe is indifferent, operating on scales of distance, time, and energy that render human concerns trivial. Yet our curiosity, ingenuity, and perseverance allow us to detect, track, and contemplate these objects, a testament to human intelligence in the face of vast, indifferent forces. This paradox, our fragility yet our insight, mirrors the very nature of the universe itself, dangerous, mysterious, and breathtakingly magnificent. If the tension, curiosity, and cosmic perspective captivate you, then 404 Altverse is your gateway to the unknown. Subscribe and travel with us as we follow these interstellar visitors, explore their mysteries, and confront the awe and terror of the universe. Every object, every trajectory, is a lesson in physics, a meditation on uncertainty, and an invitation to wonder. As the object passes through the solar system, continuous monitoring remains critical. Observatories refine measurements, track rotation, and analyze light curves for signs of surface composition. Even subtle deviations in path or brightness could reveal unknown phenomena, unusual material, surface features, or behaviors that defy expectations. Each signal, however faint, is a whisper from a distant world, billions of years old, now brushing past our sun, carrying stories of formation, evolution, and survival across interstellar space. The universe is speaking in subtle, elusive ways, and scientists listen intently, aware that every observation is both revelation and mystery. The potential consequences, though unlikely, are sobering. A direct collision with Earth is improbable, yet even a near miss could perturb asteroid belts, comets, or planetary orbits over millennia. The solar system is not a rigid, predictable machine. It is a network of gravitational interactions, energy transfers, and chaotic possibilities. An object from outside, moving at immense speed, introduces a variable humanity has little experience handling. The universe is indifferent, operating on laws we can model but never fully control. In this indifference lies both danger and awe, a reminder that our knowledge is limited, yet our curiosity persists. Finally, the arrival of this interstellar object is a narrative about the unknown. It embodies the unpredictable, the alien, and the sublime. Its passage challenges assumptions, inspires curiosity, and underscores the fragility and resilience of human observation. Harvard scientists watch, model, and reflect, aware that the universe is neither hostile nor benevolent. It simply exists, vast, dynamic, and incomprehensible in ways that continually stretch the boundaries of human understanding. The universe, with its interstellar wanderers, cosmic energy, and indifferent vastness, is both terrifying and beautiful. Every observation of such an object is an opportunity to glimpse forces, processes, and histories far beyond human scales. In studying it, we confront not only physics but philosophy, existential risk, and the extraordinary reality of our place in the cosmos. In the end, these objects remind us that the universe is alive with motion, energy, and mystery. They are messengers from distant stars, fragments of systems we can never visit, and silent harbingers of the indifference and wonder inherent in the cosmos. They challenge us, frighten us, and inspire us, and in confronting them, we deepen both our knowledge and our awe. The interstellar object passes, but its questions remain, rippling through minds, instruments, and equations alike. It reminds us that the universe is immense, unpredictable, and awe-inspiring. To track, study, and contemplate it is to participate in the grandest adventure imaginable. The pursuit of understanding, the confrontation with the unknown, and the embrace of the cosmic sublime.